In this lesson, our goal is just to push our understanding of integrals and their relationship with the derivative a little bit further. That being said, most of these are pretty straightforward. So if you want to skip around here, feel free to do so. Like if you want to skip to just the last one, which is the only really interesting one, feel free. If you think you can solve the rest of these on your own. There's two facts that I want you to keep in mind as you tackle these. So the first fact is that integration is anti-differentiation. So the way we're going to solve all of these is by going to our derivatives reference and looking to see which rule we might have used for which function to get this result. The second fact is that taking the derivative of your correct answer should give you the question. It's kind of like Jeopardy, right, where the answers are the question and the question is the answers. So a test taking strategy you can use on these multiple choice ones especially is you could take a derivative of each of the answer choices and see which one gives you secant x tangent x, and that's going to be your correct answer, right? That also means you can check your work every single time, so there's no reason you should get an integral wrong unless they truly stump you and you don't even know how to take the derivative on these multiple choice ones. Okay, that all being said, the first one then is very easy. So when I look at my derivative sheet, whoops, there we go, I find that the derivative of secant is secant x tangent x. So that means that the integral of secant x tangent x is secant of x plus c. So that's all we're doing here. We can look up every single one. I'm not going to do that every time. So just keep that in mind if I say like, okay, the integral of cosine is negative sine or something like that, know that I'm getting that from that reference sheet that I just showed you. Okay, next one gets a little bit more interesting. Still pretty straightforward as long as you remember that E is a number. By the way, there is a fifth answer choice, choice E here, that is important. That I accidentally cut off and I confused myself there for a second because E is the correct answer here, and I'll show you why. So it has to do with the fact that E is a number. Actually, here's an interesting way I can rewrite this. If E is about 2.71, I can rewrite this as the integral of e to the x plus 2.71 dx, right? Then that integral is equal to, well, the derivative of e to the x is e to the x, right? That means the antiderivative of e to the x is still e to the x. The derivative, or the integral rather, of a constant is that constant times x. And remember, 2.71 and e are interchangeable in this case. So that's my result here. Okay. So just like a little bit tricky, but you guys know what e is, then that e is a number. So nothing crazy. Moving right along here. Here's where we get a little bit more challenging. There's a couple different ways that we could tackle this, but the only way you know how to do it right now is by rewriting it. So what I mean by that, x minus 1, square root of x, and I'm going to change square root of x rather to x to the 1/2, and that's going to allow me to distribute this. So I'm going to go boom, boom. That gives me the integral of x to the 3/2, because x to the first times x to the 1/2, 1 plus 1/2 is 3/2, minus x to the 1/2 dx, and now it's just a power rule integral, right? So I'm going to add 1, that gives me x to the 5/2, and then I need to multiply by the reciprocal to get a plain old x when I take the derivative, right? So 2/5, and then when I take the derivative of this, I would do 5/2 times 2/5, and that would give me that plain old x with no coefficient that I want. And then here, x to the 3/2 minus, or times 2/3, for the same reason as I picked 2/5, right? Plus c. And that is choice D. that multiply by the reciprocal piece is a really important piece of these power rule integrals, as you have seen. All right, moving right along. This one is fairly easy, okay? So the integral of the integral of cosine is sine is what I want to say, right? So sine of 3x plus c would be a good guess. However, remember when we take the derivative of this, so the derivative of sine of 3x is going to be cosine of 3x, which is what we want, and then chain rule times the derivative of 3x, which is times 3. So that's 3 cosine of 3x. Okay, so we don't want 3 cosine of 3x, we want plain old cosine of 3x when we take that derivative. So I'm going to add a 1/3 here, just like I did on my power rule 1. Then when I take that derivative, if I wanted to check my work, 3 times 1/3 would cancel out, and we're left with that imaginary 1 we got there, right? So just like chain rule is a major culprit for students getting problems wrong in derivatives, it can be the case also here in integrals as well. Okay, now for the moment we've both been waiting for. Oh, no, just kidding. We have one more. This, again, is one where I rewrite them. So the only way you know how to tackle this is by rewriting right now. So I'm going to square this, and I could use a Punnett square to do that. I'm just going to do it in my head. Probably a lot of you are at that point too. So 9x squared minus 6x minus 6x would be minus 12x plus 4. It's going to be what I get when I square that. And this is still the integral. This is a definite integral now from 0 to 1 of this whole mess dx. And then we are going to use the reverse power rule, right? So 9 over 3. And I can simplify this a bit later if I want, right? Minus x squared and then 12 over 2. Because this will give me a 12 when I multiply those to take the derivatives, plus 4x. And I'm evaluating that from 0 to 1. Well, let's see, I get 3x to the third minus 6x squared plus 4x from 0 to 1. And then this would be just, I'm plugging in 1 now. 3 minus 6 plus 4 minus a whole bunch of zeros, right? 0, 0, 0. Okay. So 3 minus 6 plus 4, it's a negative 3 plus 4 is 1. And now we have another definite integral. The integral of sine, careful here, the integral of sine here is negative cosine of x. And that's because the derivative of cosine of x, remember, is negative sine x. Okay. So when we take the derivative of cosine, the sign flips, in other words. So our integral should also have of sine should also have the opposite sign. So when I take the derivative of this, I would get a positive sign, right? So we're going to evaluate that from 0 to pi over 4. And let's see now. So cosine of pi over 4 is root 2 over 2 minus cosine of 0 is 1, right? But that is also negative because of our negative here. So minus a negative 1. So we have to be very careful with our signs here. This ends up being a positive 1. So negative square root 2 over 2 plus 1. Notice, those of you who have been studying how to integrate on your calculator, notice we could not have done that one on our calculator. I guess unless we also punched in all these answer choices to see which decimal result would be equal to the answer choice we wanted, because this would give us a decimal. Last one. Here's the cool one that I was excited to get to. So we want the integral from negative 1 to 1 of f. So pretty standard, except f is this piecewise function. Okay? So let's think about what we're talking about, right? So we have this function And it's negative 1 at x equals 0. And then to the left, it's a parabola. And we know, like, this parabola would look like that, right? Just a plain old parabola. To the right, it's a line. Okay, so if we're talking about an integral from negative 1 to 1, we're talking about this area plus this area, where this is negative 1 and this is 1. So that's what we're doing, right? So the area under our parabola to the left, and then the area under our straight line to the right. That's not looking super straight. I don't think I can fix it. I can label it though. So this is x. This is x squared. Well, what we can do is we can just break this up. So this integral here is equal to the integral from negative 1 to 0 of x squared plus the integral from 0 to 1 of x. And notice we don't actually need this negative 1 at all. If you think really hard, you actually probably know the reason why. And then we just integrate and solve it. So we get x to the third over 3 evaluated from from negative 1 to 0 plus x squared over 2 evaluated from 0 to 1. Okay. So let's be careful as we do these, right? So we get 0 minus negative 1 to the third over 3 plus 1 squared over 2 minus 0, right? 0 over 2. And this 1 is going to be negative. Negative 1 to the third is negative times another negative is a positive. So we get 1/3 plus 1/2, which is 5 over 6 when you do that math. So 2/6 plus 3/6 is 5/6. So there we go. So it's always a fair move to break an integral into pieces like that. And then when you have a piecewise function, that's what we're going to do, and we're going to do that based on the domain of each piece.